Alright, so in this video I'm going to be talking about another approach for event extraction, but the domain is just commodity news, and we are using graph convolutional network. And because dependence, if you write the dependency parse, it's like an adjacency matrix. So you give adjacency matrix. With adjacency matrix, you can create a graph, and then you learn that graph using convolutional graph convolutional network. So I'm gonna be focusing on this paper in 2021. Event extraction in commodity news is a less researched area as compared to generic event extraction. However, accurate event extraction from commodity news is useful in a broad range of applications, such as understanding event chains and learning event-event relations, which can then be used for commodity price prediction. The events found in commodity news exhibit characteristics different from generic events, hence posing a unique challenge in the event extraction using existing methods. This paper proposes an effective use of graph convolutional networks with a prune dependency tree terms, contextualized subtree for better event extraction in commodity news. So this paper is in Monash University. So we use Convert. We introduce Convert for feature embedding. It's a BERT-based masked language model that was produced through domain adaptive pre-training. An example of a sentence from a piece of commodity news. So you see that crude oil inventory increase or oversupply. So these are the events. And you see that we are using trigger word is in bold. And we have entity type for each entity mention, which is in blue. And we use this beginner, intermediate, outer tagging format. So for event extraction of crude oil inventory increase event, we have these entity mentions and these argument roles. You see different argument roles. But in biomedical domain, for example, we have cause, we have theme, we have site, different kinds of roles. And you see different type. It should be fair. So, for example, some of them are near each other, but this one, cause movement down loss, has more sentences for training. Syntactic dependency graphs represent sentences as directed trees with head modifier dependency arcs between related words. Each word in such graphs is surrounded by its direct syntactic governor and dependent words, over which convolution net operations can be performed on the most relevant words and avoid the modeling of unrelated words. Rather than using the full dependency parse tree, we propose to use a uniquely pruned dependency tree that is made up of the shortest path between two nodes, the trigger candidate and entity mention, and additional off-path nodes. The off-path nodes are included to provide additional contextual information. The resulting tree is termed contextual subtree. For example, here in the figure 3, you see that with one of many candidate contextual subtree that is highlighted, and we prune the dependency tree to obtain a subtree, but rooted at the least common ancestor between trigger candidate and the entity mention candidate, while also contains off-path nodes. These off-path nodes provide additional and crucial context that enable better results in argument role classification. Off-path information is made up of tokens that are up to distance away from the dependency path. The usage of contextual subtree is targeted at argument role classification. The subtask within event extraction that classifies the argument role each entity plays in an event. Entity candidates are classified into one of the 19 argument roles. So here, the left one shows the subtree with LCL path between the event trigger and argument, but the right one shows a slightly different subtree that not only contains the LCA path, but also off-path information. So below are 3 examples of contextual subtrees between an event trigger and entity mention. Off-path information are in italics, and these examples, the off-path words are prepositional words that help with correct classification of entity mentions argument role, even though all the entities are of the same type, namely quantity. So you want to build subparse tree from dependency head indices. Then the result is just a subtree structure. First we convert head indices to tree object. If distance is less than 0, then build the whole tree. Otherwise, we find all ancestor nodes of the trigger, we find all ancestor nodes of the entity, and we find lowest common ancestor. Then we generate path nodes, then we insert more nodes based on the distance away from path nodes. So apart from famous bank example where the word could mean financial institution or terrain, this part of the river, there are some commodity specific polysemous words in the commodity news corpus that can be better represented with further pre-training with in-domain data. For example, stocks, it will be inventory shares. Tank is storage vessel, market, could be anything. The commodity news is made up of about 20k news articles. And we initialize this convert with bird-based case. So this is the architecture. First, we give it to convert, so we have a good embedding layer. Then we do trigger classification. Now we are ready to create the graph because we know the dependency parts of that. So we get the subtree, not all of them, just subtree between the trigger and the mentions. We have a subtree. And then we learn this graph neural network because we know how to learn it. We have a classifier, so the loss is back propagated, and the weights of graph neural networks is updated and is learned. And now we have argument role label. So we use this graph convolutional network, but the important thing, we just get the adjacency matrix using dependency parse informations. That you can use Stanford Core NLP, you can use Allen Institute for AI, you can use Spacey, you can use SciSpacey, you can use many new libraries for dependency parse. Each one has pros and cons, but it's freely available. You don't need to learn your own dependency parser. Of course, I have a playlist for dependency parsing that you can train your own model based on your own data, but why not you just use these available dependency parsers? Although the error is propagated downstream, so if your parser is not good, so the results would be awful. Then you see the entity encoding trigger entity pair. We concatenate the subtree, the target and the entity, and then it's just a linear network. We have bias, we have weight, and then G is just a softmax. Then you get the trigger. But we learn it jointly. I mean, both argument and target. Of course, we have beta as a trade-off between these two losses. And as I said, we have trigger identification and classification. We have argument identification and classification in any event extraction task that you have. And you see a fun score. For this particular data set, they had 90%. Because they are focusing on a particular data set. But we know that state-of-the-art accuracy is less than 75 for even biomedical event extraction, for even the simple ACE 25,